Good morning, I am Devasena. In this lecture, we are going to discuss about condition of symmetry, that is, symmetrical two-port network. This topic is present in the subject circuit analysis under the unit two-port networks. Let's start discussing about a symmetrical two-port network. A symmetrical network is one which can be exactly divided into two identical sections. In a symmetrical two-port network, the looking back impedance from port 1 and port 2 will be the same. Hence, in a symmetrical network, the input and output ports can be exchanged. Let us discuss the condition of symmetry. If the impedance measured at one port is equal to the impedance measured at the other port with remaining port open circuited, the network is said to be symmetrical network. The impedances at two ports can be measured as shown in figure A and figure B. This is figure A. Here we have considered V1 is equal to Vs and output current I2 is equal to 0, that is output current is open circuited. This is figure B. Here we have considered V2 is equal to Vs and input current I1 is considered to be open circuited, that is I1 is equal to 0. This is represented in figure B. Condition of symmetry for Z parameters. The basic equations of Z parameters are as follows. That is V1 is equal to Z11 I1 plus Z12 I2. Consider this as equation 1. That is, input voltage V1 is the function of input current and output current. Now consider V2 is equal to Z21 I1 plus Z22 I2. Consider this as equation 2. That is, output voltage is the function of input current and output current. Now consider figure A. This is the representation of figure A. Here we have considered V1 is equal to Vs and I2 is equal to 0. Hence, equation 1 will become Vs, that is Z11 I1. Here we have substituted V1 as V suffix S and we have already considered the value of I2 as 0. Therefore, Z12 I2 term will not be available here. Therefore, Vs by I1, that is equal to Z11. Consider this as equation 3. Now consider figure B. This is the representation of figure B. Here, output voltage V2 is equal to Vs and we have considered input current I1 is equal to 0. That is, input current is open circuited. So we have V2 is equal to Vs and I1 is equal to 0. Hence, equation 2 will become Vs is equal to Z22 I2 because we have substituted V2 is equal to Vs and we have considered I1 is equal to 0. Therefore, Vs by I2 is equal to Z22. Consider this as equation 4. Thus, for condition of symmetry, the equation is Vs by I1 is equal to Vs by I2. That is, from equation 3 and 4, we have the value of Vs by I1 as Z11 and the value of Vs by I2 is equal to Z22. Therefore, Z11 is equal to Z22. This equation represents the condition of symmetry for Z parameters. Let us start discussing about the condition of symmetry for Y parameters. The basic equations of Y parameters are as follows. I1 is equal to Y11 V1 plus Y12 V2. Consider this as equation 5. That is, input current I1 is the function of input voltage and output voltage. Now, I2 is equal to Y21 V1 plus Y22 V2. Consider this as equation 6. That is, output current is equal to, output current is the function of input voltage and output voltage. This is represented here. Now consider figure A. This is the representation of figure A. Here we have V1 is equal to Vs and I2 is equal to 0. Therefore, equation 5 can be written as I1 is equal to Y11 Vs plus Y12 V2. Consider this as equation 7. Equation 6 can be written as 0 is equal to Y21 Vs plus Y22 V2 because we have considered I2 is equal to 0. Therefore, V2 is equal to minus Y21 Vs divided by Y2. Consider this as equation 8. Substituting the value of V2 from equation 8 in equation 7, we have I1 is equal to Y11 Vs plus Y12 into minus of Y21 by Y22 into Vs. Now consider figure B. This is the representation of figure B. Here we have considered V2 is equal to Vs and I1 is equal to 0. That is, V2 is equal to Vs and I1 is equal to 0. Equation 5 can be written as 0 is equal to Y11 V1 plus Y12 Vs. Consider this as equation 10. Therefore, minus Y11 V1 is equal to Y12 Vs. That is, V1 is equal to minus Y12 by Y11 into Vs. Consider this as equation 11. Equation 6 can be written as I2 is equal to Y21 V1 plus Y22 Vs. Consider this as equation 12. Substituting the value of V1 in equation 12 from equation 11, we have I2 is equal to Y21 into, open the bracket, minus Y12 by Y1 into Vs plus Y22 Vs. Therefore, I2 is equal to, open the bracket, minus Y12 into Y21 divided by Y11 plus Y22, close the bracket, into Vs, because we have taken Vs term as a common. That is, I2 is equal to, open the bracket, Y11 Y12 minus Y12 Y21 divided by Y11, close the bracket, into Vs, because we have taken the LCM. Therefore, Vs by I2 is equal to Y11 by y11 y22 minus y12 y21. Consider this as equation 13. For condition of symmetry, Vs by I1 is equal to Vs by I2. So from equation 9 we have the value of Vs by I1, and from equation 13 we have the value of Vs by I2. If you substitute these values from equation 9 and 13, we get y22 the whole divided by y11 y22 minus y12 y21, that is equal to y11 the whole divided by y11 y22 minus y12 y21, that is y11 is equal to y22. This equation represents the condition of symmetry for y parameters. Let us start discussing about the condition of symmetry for h parameters. The basic equations of h parameters are as follows. V1 is equal to h11 I1 plus h12 V2. Consider this as equation 14. And I2 is equal to h21 I1 plus h22 V2. Consider this as equation 15. That is, the h parameters can be represented as V1 is the function of I1 and V2. Similarly, I2 is the function of I1 and V2. This is represented in equations 14 and 15. Consider figure A. This is the representation of figure A. Here we have V1 is equal to Vs and I2 is equal to 0. That is, input voltage is considered to be Vs and output current is considered to be open circuited. Therefore, equation 14 can be written as Vs is equal to h11 I1 plus h12 V2. Consider this as equation 16, because here we have substituted V1 is equal to Vs, and equation 15 can be written as 0 is equal to h21 I1 plus h22 V2, because we have considered I2 as 0. Therefore, minus h22 V2 is equal to h21 I1. So V2 is equal to minus h21 by h22 into I1. Consider this is equation 17. Substituting the value of V2 from equation 17 in equation 16, we have Vs is equal to h11 I1 plus h12 into, open the bracket, minus h21 divided by h22, close the bracket, into I1, because we have substituted the value of V2 from equation 17. And Vs is equal to, open the bracket, h11 minus h12 into h21 divided by h22, close the bracket, into I1, because we have taken the term I1 as a common. So Vs is equal to, open the bracket, h11 h22 minus h12 h21 divided by h22 into, close the bracket, into I1. We have taken the LCM. That is, Vs by I1 is equal to h11 into h22 minus h12 h21 divided by h22. Consider this as equation 18. Consider figure B. This is figure B. V2 is equal to Vs and I1 is equal to 0. equation 14 can be written as V1 is equal to H11 I1 plus H12 Vs. Consider this is equation 19. Equation 15 can be written as I2 is equal to H22 Vs. Therefore, Vs by I2 is equal to 1 divided by H22. Consider this is equation 20. For condition of symmetry, we have Vs by I1 is equal to Vs by I2. From equation 18 and equation 20, we have H11 H22 minus H12 H21 divided by H22, that is equal to 1 by H22. H11 H22 minus H12 H21 is equal to 1. This is the condition of symmetry for H parameters. Let us discuss about the condition of symmetry for transmission parameters. The basic equations for the transmission parameters are as follows. V1 is equal to AV2 plus B into minus I2. Consider this is equation 21. I1 is equal to C into V2 plus D into minus I2. Consider this as equation 22. In this transmission parameters, we have represented V1 in terms of V2 and minus I2. Similarly, I1 in terms of V2 and minus I2. This is represented in equation 21 and 22. Consider figure A. This is the representation of figure A. Here we have considered V1 is equal to Vs and I2 is equal to 0. That is, we have considered input voltage as Vs and output current is considered to be open circuited. So, equation 21 can be written as Vs is equal to A into V2. Consider this as equation 23 because we have substituted V1 as Vs and we have considered I2 as 0. So the term Bi2 is not available in equation 23. Similarly, equation 22 can be written as I1 is equal to C into V2. This is considered as equation 24. Therefore, V2 is equal to I1 divided by C. Substitute the value of V2 from the above equation in equation 23. The equation 23 becomes Vs is equal to A into I1 divided by C. That is, Vs by I1 is equal to A divided by C. Consider this as equation 25. Consider figure B. This is the representation of figure B. Here V2 is equal to Vs. That is, output voltage is considered to be Vs and I1 is equal to 0. That is, input current is considered to be open circuited. Therefore, equation 21 can be written as V1 is equal to AVs plus B into minus of I2. Consider this as equation 26. Equation 22 can be written as 0 is equal to C into Vs plus D into minus I2. Therefore, CVs is equal to dI2. That is, Vs by I2 is equal to D by C. Consider this is equation 27. For condition of symmetry, we have Vs by I1 is equal to Vs by I2. So, from equation 25 and equation 27, we have A by C that is equal to D by C. That is, A is equal to D. This is the condition of symmetry for transmission parameters. Thank you very much for listening to this lecture. For further updates, kindly subscribe this channel. If you like this video means you can share this video with your friends.